let's look at this problem here. We have R is the region bounded above by the graph of this and below by the line y equals 2. So I went ahead and graphed it over here. You can see that what we're talking about is this is the region here. And so we have to figure out the area. So the top curve is going to be this first function, and then the second curve is this line y equals 2. So we have to figure out where these two things intersect, set them equal to each other, and what do we get? We have 20 over 1 plus x squared equals 2. I would suggest using the calculator on this just so you don't have to waste time with it, but if you were to do it by hand, you would just cross multiply this out and you would get what? 2 plus 2x squared equals 20. Divide everything by 2, you get 10 is equal to 1 plus x squared. Subtract 1, you get 9 equals x squared, so plus or minus 3. So negative 3 over here and positive 3 over here. So the top curve is 20 over 1 plus x squared minus 2. And we're just going to integrate that from negative 3 to 3 and see what we get. I've already put this in the calculator, right? I'll show you what I did here. So I got y1 is the first function and y2 is just the line y equals 2. So we should be able to go here and do a math and do the integral, which is, I think, number 9. No. Try that again. Yeah, number 9. So we're going to take the integral from negative 3 up to 3. And we have what? Let's see if I can put the bars in there. y1, and that's with respect to x, and do the same thing for the second curve, number 9, negative 3 to 3, I suppose we could do it faster without using these bars, but and that's with respect to x also, right? Okay. So we get some area here, 37.961. And pause that. Okay. I just wanted to check my notes, make sure that was right. Now that's for part A. Part B says find the volume when we rotate this solid about the line, about the x-axis. Okay, so we have a rotation problem. So remember, volume is pi r squared times h, and when we do the integral here to solve this, our h is going to be our dx, and the large radius is going to be the top function, and the bottom radius is going to be from 2 down to the bottom. So since we're squaring it, switch back here, we'll say that we have what? 20 over 1 plus x squared, all of that squared, minus 2 squared, and we should be good to go. So since I already have this one in the calculator, let's see if I can do a shortcut here. Recall the last one, and if I can do this, second insert, and let's square that. I'm going to try to do the same thing over here. Square this one. Could just as easily type in the number 4, I suppose. Oops. Don't know what I just did there. Try it again. Okay. Slowly but surely we're getting there. Second insert, and square it. And then don't forget we still have to multiply this by pi, right? So multiply that answer by pi. And we're going to get quite a large number. 1871.190. Alright, not too bad. Just double check my notes, make sure that's the correct response for it. Okay, let's go on to part C. Part C says that we are looking for the region is a solid of cross sections that are semicircles, and we are perpendicular to the x-axis. So I don't know if I can really draw these very well. Let's give it a shot. Let's see. So we're going here inside of our area that we had earlier, and we're constructing semicircles. And of course there's some thickness to this, and if we go draw another one, yeah, let's try that again. Let's try a small one right over here. So we have a semicircle there, and of course the semicircles get bigger and bigger, right, as we stack them on top of each other. So the area formula for a circle is pi r squared. So if we have a semicircle, we have half of that. And what is the radius of my semicircle? So I just turn this one sideways. What we have drawn here, we show the whole diameter, right? So we need to find half of that to be our radius, right? So whenever I put my integral formula together, we're going to have 1/2 pi out in front, and our radius squared is going to be half of top curve minus bottom curve, right? I don't know if I did enough space there. Let's give ourselves plenty of space here. And this is dx. Alright, so we have what? 20 over 1 plus x squared minus 2. Okay. And this is a little shortcut. We're going to have to distribute this square to both of these members, right? Well, the first one, if we square 1/2, we get 1/4. So 1/4 can become another constant. So if you multiply 1/4 times 1/2, you get that pi over 8 is our constant. And we're still going from -3 to 3. And so now what do we have is this squared. So I think we can probably use the calculator again on this one. This is in y1 if you recall. That's in y2. So we could just put this as one integral and square it. So let's see if we can recall that last one. Yep, I think this is it. So we're going to delete this. There we go. Might have been faster just to type it in. Okay, so let's take a look at what we have. We don't need that square term right there. We need to get inside of here. And let's see. Let's insert some parentheses just to make it easier. So let's do y1 minus y2 and let's close that first parenthesis there and square this whole term. And let's see. And then we're going to get an answer. Whoa, syntax error. Let's go to it and see if we can figure out what we did here. Perhaps this isn't so easy. Y1 minus Y2 try to put another parenthesis in there. Let me pause this and figure this out. Okay, I figured out what happened. There was another square term out here that I didn't see outside of the dx. So anyway, so I just did y1 minus y2 squared, and then remember I still need to multiply this answer by pi over 8. So times pi over 8, and we should get 174.268. So that should be it for that one.